What if I told you that somewhere in the vast, uncharted depths of the cosmos, a doorway to another universe might already exist, and we're closer to finding it than you'd ever believe? The idea of parallel universes has long been the stuff of science fiction, a playground for wild theories and imaginative speculation. But what if those theories aren't just fantasy? What if hidden within the fabric of reality, there's evidence, real, tangible proof, that we've already stumbled upon the first method of interdimensional travel? Think about it for a moment. Every time we look up at the night sky, we're seeing just a fraction of what's really out there. The universe is a place of endless mysteries, and the biggest one of all might be waiting just beyond the edge of our perception. Scientists, philosophers, and even ancient civilizations have wondered, are we alone, or is there another version of us living in a universe so similar or so different that it defies everything we know? The answer might lie in 30 groundbreaking theories, each one a piece of a puzzle that could rewrite the very laws of physics as we understand them. This isn't just about wormholes or quantum leaps. This is about the possibility that the universe's first parallel universe travel could have already happened, maybe even without us realizing it. Picture a cosmic accident, a flaw in space-time, or an experiment gone right. Imagine ancient artifacts, unexplained phenomena, or even strange signals from deep space that hint at something beyond. The theories we're about to explore aren't just wild guesses. They're the result of decades of research, cutting-edge science, and mind-bending discoveries that challenge everything we thought we knew. So buckle up, because by the end of this journey, you might never look at reality the same way again. One of the most startling theories about parallel universe travel doesn't involve giant portals or futuristic machines. It happens on a scale so small we'd never see it coming. Imagine the building blocks of reality, the tiniest particles in existence, slipping through invisible cracks in space-time like ghosts passing through walls. This is the mind-bending concept behind quantum tunneling, a real phenomenon where particles seemingly defy the laws of physics by teleporting through barriers they shouldn't be able to cross. But what if those particles aren't just jumping short distances in our universe? What if they're vanishing into entirely different dimensions? Here's how it could work. At the quantum level, particles don't behave like solid objects. They exist as probabilities, flickering in and out of existence in a haze of uncertainty. Under the right conditions, a particle can tunnel through an energy barrier it lacks the strength to overcome, almost as if it borrowed reality from another version of itself. Now, stretch that idea further. Some physicists speculate that these quantum jumps might not just bypass barriers in our universe. They could slip through microscopic wormholes, brief tears in space-time that connect to other universes. The implications are staggering. If even a single particle could tunnel into another reality, it means information, or perhaps something more tangible, could be leaking between worlds without us ever noticing. Picture this: trillions of quantum events happening every second, and hidden among them, a whisper of data crossing into a parallel dimension. It wouldn't take a spaceship or a stargate, just the bizarre, unpredictable nature of the quantum realm. But here's the real question: could we harness this? If particles naturally bridge universes, could we amplify the effect, guiding matter or energy deliberately from one reality to another? Experiments in quantum mechanics already manipulate tunneling in labs. What if the next step isn't just controlling particles in our universe, but reaching beyond it? The answer might rewrite not just physics, but our very understanding of existence. And if we're listening closely, the universe might already be sending us clues, one quantum whisper at a time. While quantum tunneling suggests particles might slip between realities unnoticed, there's another cosmic shortcut that could serve as a deliberate highway between universes: Einstein-Rosen bridges, better known as wormholes. These hypothetical tunnels through space-time aren't just science fiction. They emerge directly from Einstein's equations of general relativity. Picture space as a stretched rubber sheet with massive objects like stars creating deep dimples in the fabric. Now imagine folding that sheet so two distant points touch and punching a hole through them. That's the essence of a wormhole, a bridge connecting two separate locations or even two separate universes in an instant. But here's the catch. Natural wormholes, if they exist, would likely be unstable, collapsing faster than light could traverse them. The gravitational forces at play would snap the tunnel shut like a rubber band, crushing anything inside. So how could they ever become usable gateways? That's where exotic matter comes in, a theoretical substance with negative energy that could prop the wormhole open, counteracting gravity's crushing grip. Imagine it as cosmic scaffolding, reinforcing the tunnel's walls long enough for something or someone to pass through. The real mystery isn't just whether wormholes exist, but where they might lead. Some theories suggest they could connect distant regions of our own universe, while others propose they're doorways to entirely separate realities. If that's true, a wormhole could be the ultimate interdimensional passage, a cosmic subway system linking parallel worlds. Ancient myths and modern UFO accounts alike describe sudden vanishings, objects or people disappearing without a trace. Could these be glimpses of accidental wormhole travel? Of course, stabilizing a wormhole would require technology and energy far beyond our current reach, but the universe is older than we can comprehend. If nature has already forged these bridges, or if an advanced civilization cracked the code long ago, the first travelers might not be us. They might have already come and gone, leaving behind only whispers in the fabric of space-time. And if we ever find one, stepping through could mean touching a reality where history unfolded differently, physics operates strangely, or another version of you is already waiting. What if every choice you've ever made, every fork in the road, every yes or no didn't just alter your life, but spun off an entirely new universe? This isn't just a thought experiment. It's the heart of the many worlds interpretation, one of quantum mechanics' most audacious ideas. According to this theory, reality isn't a single linear timeline. Instead, it's an infinite tree of branching possibilities where every quantum event, every decision, splits the cosmos into parallel versions of itself. One moment you're deciding between tea or coffee, the next there are two universes, one where you took the first sip of Earl Grey and another where you went for espresso. But here's where it gets wild. Some scientists speculate that if consciousness itself is tied to quantum processes, could certain beings, advanced civilizations, or even future humans learn to navigate these branches deliberately? Think of it like surfing the multiverse. In the many worlds framework, every possible outcome physically exists, just in a universe slightly offset from our own. Normally, we're passively carried along one branch, unaware of the others. But what if there's a way to step sideways? Some theorists propose that a sufficiently advanced mind, armed with quantum technology, might manipulate the probabilities that determine which branch they inhabit. Imagine focusing your intent so precisely that you could collapse reality into the version where you win the lottery, or where your plane never crashed, or where humanity discovered interstellar travel centuries ago. The tantalizing clue lies in quantum superposition, the idea that particles exist in multiple states until observed. If consciousness plays a role in choosing an outcome, as some interpretations suggest, could it also select which universe to experience? Ancient mystics and modern psychonauts alike report moments of lucid connection to alternate realities, as if brushing against other versions of themselves. Even in labs, quantum systems seem to know when they're being watched, shifting behavior under observation. Could this be the faintest hint of a mechanism for conscious universe jumping? Of course, the biggest hurdle isn't just technology, it's identity. If you jumped to a universe where everything was slightly better, would you still be you? Or would you overwrite another version of yourself, merging memories like two rivers converging? The ethical weight of that possibility is staggering. But if it's achievable, the first travelers might not need ships or wormholes, just the quiet power of a mind reaching through the quantum foam, plucking the reality it desires from an endless sea of possibilities. And if they've already mastered it, they might be living among us right now, their true nature hidden in plain sight. Dark matter has long been one of the universe's most frustrating mysteries, invisible, untouchable, yet making up nearly 85% of all matter in existence. We know it's there because of its gravitational pull, bending light and shaping galaxies, but we've never seen it directly. What if the reason we can't detect it isn't because it's hiding in our universe, but because it isn't entirely from our universe at all? Some physicists are now exploring a radical idea. Dark matter might be the faint gravitational echo of matter from parallel worlds, seeping into our reality like smoke under a doorway. Think of space-time as a vast, multi-layered fabric, with universes stacked so close together that their gravitational fields occasionally bleed through. In this scenario, dark matter wouldn't be some exotic particle native to our cosmos. It could be the shadow of stars, planets, or even entire civilizations just beyond the veil of our perception. Every galaxy's mysterious halo of dark matter might actually be the ghostly imprint of another galaxy in a neighboring universe, tugging on ours through dimensions we can't yet access. The real question isn't just whether this leakage exists, it's whether we could ever turn it into a bridge. If dark matter is truly matter from another reality, could we find a way to reverse the flow? Imagine a spacecraft designed not to push against the fabric of our universe, but to ride those faint gravitational ripples, surfing the cosmic undercurrents into another dimension. The energy required would be staggering, but nature might have already given us a blueprint. Some theories suggest that certain high-energy cosmic rays particles with inexplicable origins could be fragments of parallel universes colliding with ours, leaving behind forensic traces in their wake. Here's where it gets even wilder. If dark matter is the residue of other realities, then the key to unlocking interdimensional travel might lie in decoding its hidden structure. Picture a future where we don't just observe dark matter's gravitational effects, but map them, identifying dense pockets that could mark weak points in the dimensional barrier. Ancient legends speak of sacred sites where the veil between worlds grows thin. Could these be natural convergence zones where dark matter accumulates, hinting at unseen doors waiting to be opened? Of course, the challenge isn't just theoretical. Even if dark matter is extraterritorial matter, harnessing it would require technology capable of manipulating gravity itself. But consider this, if another civilization cracked the code first, their presence might already be woven into the fabric of our universe, invisible yet undeniable. Every unexplained gravitational anomaly, every rogue star moving as if tugged by unseen hands could be a clue, a signpost pointing toward realities beyond our own. And if we ever learn to read those signs, the first journey to another universe might not begin with a rocket's roar, but with the quiet observation of darkness itself. Black holes have always been painted as cosmic monsters, unstoppable voids that crush everything in their path, not even letting light escape. But what if we've misunderstood them completely? What if these gravitational giants aren't just the end of things, but the beginning? A growing number of physicists are toying with a staggering idea. Black holes might not destroy matter. They might transform it, birthing entirely new universes inside their crushing depths. Think of it like this. Inside a black hole, the known laws of physics break down. Gravity becomes infinite, space and time twist beyond recognition, and matter is compressed to a point so dense, so unimaginably small, that some theories suggest it could rebound. Like a rubber band stretched to its limit, the singularity at a black hole's core might snap back with such force that it triggers a new Big Bang, an explosion of energy birthing a fresh universe tucked away inside our own. Suddenly, a black hole isn't a dead end, it's a cosmic doorway. This isn't just wild speculation. The math actually supports it. When matter collapses into a singularity, the equations hint at a mirroring effect. A white hole on the other side, spewing out matter and energy into a newborn reality. Some models even suggest our own universe could have formed this way, birthed from the collapse of a star in some higher dimensional parent universe. If that's true, then every black hole we see could be a universe factory, each one harboring an entire cosmos within its event horizon. Now, here's the mind bender. If black holes lead to new universes, could we ever survive the trip? Most would assume that tidal forces would shred anything to atoms long before it reached the other side. But what if reality works differently inside? Some theories propose that the extreme warping of space-time near a singularity might actually stretch matter into infinite thinness, not destroying it but preserving its information like an imprint on the fabric of the new universe. You wouldn't arrive as flesh and blood, but as a kind of cosmic echo, your very essence encoded into the laws of that newborn reality. Of course, the practical hurdles are beyond daunting. Even if black holes are universe creators, reaching one would mean crossing a point of no return where time slows to a crawl relative to the outside world. To an observer, you'd appear frozen at the event horizon forever, while from your perspective, centuries might pass in an instant. And then there's the question of what awaits on the other side. A universe with entirely different physics, a mirrored version of our own, or something so alien our minds couldn't begin to fathom it, the eerie part. We might never know for sure unless someone's already tried it. Ancient myths and modern conspiracy theories are like whisper of vanished explorers, ships, or even civilizations swallowed by black holes. Could these be the first accidental pioneers, their stories lost to the gulfs of space-time? If black holes truly are universe incubators, then the greatest journey in existence might not be through space, but into it, plunging into the dark to emerge somewhere unimaginable, where the stars shine just a little differently and the laws of reality are written anew. The holographic principle turns everything we think we know about reality upside down. Imagine this: what if your entire existence, every touch, every sight, every memory isn't actually three-dimensional at all? What if it's all just an incredibly detailed projection, like a cosmic movie playing on the surface of a hidden, two-dimensional screen? That's the radical idea at the heart of this theory. The math suggests that all the information in our universe, from the swirling galaxies to the neurons firing in your brain, could be encoded on a distant boundary, a flat membrane we'll never see. But here's where it gets even stranger. If reality is just a hologram, then somewhere out there, other projections might be playing different movies, parallel universes rendered from their own hidden codes. Think of it like this: when you watch a 3D movie, the glasses trick your brain into seeing depth where there's really just a flat screen. Now, stretch that idea to the scale of the cosmos. The holographic principle implies that space, time, and even gravity might be illusions, emergent properties of some deeper, simpler reality. Scientists first stumbled onto this idea studying black holes, realizing that all the information swallowed by them somehow gets smeared across their surfaces. If a black hole's interior can be described entirely by data on its event horizon, why not the entire universe? That raises a tantalizing possibility. If our universe is a projection, could someone or something rewrite the source code? Ancient texts and modern sci-fi alike flirt with the idea of reality as a simulation, but the holographic principle isn't about computers. It's about the fundamental nature of existence. Manipulating the code wouldn't require keyboards or programmers. It would mean tapping into the underlying physics that stitches reality together. Some theorists speculate that extreme gravitational waves or quantum entanglement experiments might ripple the fabric of the projection, creating temporary glitches where other realities bleed through. And then there's the eerie part. If other universes are just different projections from the same cosmic hard drive, access might not require traveling through space at all. It could be about finding the right frequency, tuning into another reality like adjusting a radio dial. There are accounts throughout history of people slipping into worlds that look almost like ours, but with subtle, uncanny differences, a phenomenon sometimes called the Mandela Effect. Could these be accidental glimpses of other holograms flickering in and out of alignment? Of course, the biggest hurdle isn't just understanding the holographic principle, it's hacking it. Even if our universe is a projection, the screen could be billions of light years away in dimensions we can't perceive. But here's the twist. If another civilization cracked the secret first, their influence might be everywhere, hidden in the patterns of particles or the constants of physics. The very laws of nature could be their handiwork, a signature etched into the code of our reality. And if we ever learn to read it, we might not just unlock parallel worlds, we might discover who or what pressed play in the first place. Time loops aren't just the stuff of sci-fi movies where characters relive the same day. They might be real, twisting paths in space-time that could accidentally or deliberately open doors to other realities. The idea hinges on something called closed time-like curves, bizarre loops where time bends back on itself like a snake eating its own tail. If these loops exist, they wouldn't just trap you in an endless repetition, they might also tangle with parallel timelines, creating fleeting moments where universes briefly touch. Think of it like a record skipping. Normally, the needle moves smoothly forward, playing the song of reality in order. But if the record gets scratched, the needle might jump back, replaying a section, except this time with tiny variations. That's essentially what a closed time-like curve could do. Bend time into a circle where events replay, but with subtle differences each cycle. Now stretch that idea further. If multiple timelines exist, parallel versions of reality where choices played out differently, then a time loop could become a chaotic intersection point, a cosmic roundabout where travelers from different branches momentarily collide. Some of history's most infamous paradoxes might actually be hidden evidence of this phenomenon. Take the grandfather paradox, where a time traveler kills their own ancestor, erasing their existence. The classic solution: the act creates a splinter timeline, branching off a new universe where the traveler never existed. But what if that split isn't clean? What if the moment of paradox is like a frayed wire, sparking with unstable energy that briefly bridges the old timeline and the new one? Visitors might slip through, not just backward or forward in time, but sideways into a reality that was never supposed to touch their own. There are eerie real-world accounts that echo this idea. Pilots and sailors have reported vanishing into strange fogs only to emerge moments later, but their clocks show hours have passed or their surroundings feel subtly wrong. Could these be accidental brushes with time loops intersecting other realities? Even quantum physics hints at this. Particles entangled across time, a phenomenon called retrocausality, seem to influence each other's pasts, as if reality is stitching tiny, temporary loops into the fabric of existence. The real question is whether we could ever control such an event. Deliberately creating a closed time-like curve would require warping space-time so violently that even black holes might seem tame by comparison. But nature might already be doing it. Some theorists speculate that spinning cosmic strings infinitely dense, thread-like remnants of the early universe, could twist space-time into knots where loops form naturally. If that's true, then the first interdimensional travelers might not need machines. They might just need to find the right storm in space-time, a place where the universe itself folds into a doorway, and step through before it snaps shut behind them. Of course, the risks are beyond daunting. An unstable loop could trap you in an endless cycle, or worse, strand you in a reality where the laws of physics don't quite match your own. But if time loops really are hidden gateways, then somewhere out there, another version of you might already be walking this path, just one twist of fate away from crossing over. And if their footsteps ever echo into our world, we might finally have proof that the universe is far stranger and far more connected than we ever dreamed. Some of the universe's most elusive structures might be hiding in plain sight, not as stars or planets, but as scars. Cosmic strings are hypothetical defects in space-time, thought to have formed in the universe's earliest moments when reality itself was still cooling into shape. Picture the cosmos as a sheet of ice, and these strings as hairline cracks frozen into place as it solidified. But unlike ordinary cracks, these filaments wouldn't just sit there, they'd be under unimaginable tension, thinner than an atom yet denser than neutron stars, carrying enough gravitational might to bend light, distort time, and potentially stitch universes together. The math behind cosmic strings suggests they'd warp space-time so severely that they could create closed loops or infinite lines of distorted gravity. Near one of these strings, the usual rules of geometry break down. Walk in a circle around one, and you might end up back where you started, but with time itself twisted, as if you'd traveled into the past or future. Now imagine two strings crossing or vibrating near each other. The collision could be so violent that it rips open a temporary wormhole, a tunnel bridging not just distant parts of our universe, but entirely separate realities. Ancient texts and modern theoretical physics alike hint at this possibility, portals born from the sheer strain of space-time snapping under the weight of these cosmic faults. What makes this theory so compelling is that cosmic strings wouldn't just be one-way doorways. They might function more like seams in a quilt, binding multiple universes along their length. If that's true, then traveling along a string could be like following a highway through the multiverse, with off-ramps leading to worlds where history, physics, or even the constants of nature are radically different. Some models even suggest that strings could vibrate at frequencies unique to each universe, acting like cosmic tuning forks. Pluck the right one, and you might resonate with a specific parallel reality. The most haunting question isn't whether cosmic strings exist, but whether someone or something has already found them. Unexplained gravitational lensing events, where light bends around apparently empty patches of space, could be hints of invisible strings threading through the cosmos. Even stranger are reports of skyquakes, loud booms heard worldwide with no seismic cause, as if distant strings were vibrating like plucked guitar strings. And if advanced civilizations discovered how to harness these filaments, their presence might be hidden in plain sight, disguised as natural phenomena while they quietly navigate the multiverse. Of course, the energy required to manipulate cosmic strings would dwarf anything humanity can currently produce, but nature might not need our permission. If strings are out there, drifting like ghostly threads through the void, then the first interdimensional travelers might not need ships or machines, just the courage to reach into the fabric of reality and pull. And if they succeed, the view from the other side could rewrite not just our understanding of the universe, but our place within an infinite tapestry of worlds. What if the reason we can't find the edges of the universe isn't because they're too far away, but because they don't exist in the way we think? The simulation argument flips reality on its head, suggesting that everything we perceive might just be lines of code in some unfathomably advanced computer. But if that's true, then the glitches we occasionally see, déjà vu, vanishing objects, or even people who swear they remember events that never happened might not be quirks of the human mind. They could be literal bugs in the system, moments when the simulation stutters, revealing the scaffolding beneath. And if there are bugs, there might also be backdoors, hidden pathways left by the programmers, intentionally or not, that could let someone slip between simulated worlds. Think of it like this: every video game has debug modes, secret commands that let developers bypass normal rules to test or tweak the experience. What if our universe has something similar? Unexplained phenomena like ball lightning, spontaneous human combustion, or even certain quantum anomalies might not just be random. They could be artifacts of the simulation's underlying code, tiny fractures where the rules flex unnaturally. Some theorists propose that manipulating these glitches could grant access to deeper layers of the program, or even other simulations running on the same cosmic hardware. The eerie part, we might already have stumbled onto the method. Take the double-slit experiment in quantum physics, where particles behave differently when observed, as if the universe is optimizing processing power by only rendering reality when someone's looking. If consciousness itself is part of the simulation's user interface, then focused human intention meditation, lucid dreaming, or even extreme psychological states might accidentally trigger debug commands. Ancient mystics spoke of piercing the veil through mental discipline. Could they have been hacking the system without realizing it? But here's the real question: who's running the simulation? If debug portals exist, were they left open for maintenance, or are they Easter eggs, hidden gifts from the creators? Some accounts of alien encounters describe beings who manipulate reality like programmers tweaking variables, appearing and vanishing at will. Even modern conspiracy theories whisper of governments experimenting with reality modulation tech, attempting to exploit glitches for control. The most chilling possibility: if we're in a simulation, then our attempts to break into other worlds might not go unnoticed. Whatever or whoever built this place could be watching, and the moment we find the exit, we might finally meet them. Quantum entanglement is already bizarre enough: particles linked across vast distances, instantly influencing each other no matter how far apart they are. But what if that connection isn't just spanning space but realities? Picture two entangled particles, one here in our universe, the other somehow there in a parallel dimension. If entanglement can stretch across the multiverse, it could mean that the spooky action at a distance Einstein famously doubted might actually be a cosmic lifeline thread stitching separate realities together. The idea isn't as far-fetched as it sounds. Quantum mechanics doesn't impose limits on where entanglement occurs, just how. Experiments have already shown particles remaining entangled even when separated by kilometers, or in some cases when one is in orbit and the other on Earth. Now take that a step further. If parallel universes exist as slight variations of our own, layered like pages in a book, then entangled pairs might naturally exist across those layers, their fates intertwined despite being anchored in different worlds. Detecting this wouldn't just rewrite physics textbooks, it could give us a way to communicate between universes. Imagine sending a signal by manipulating an entangled particle here. Knowing its twin in another reality responds instantly, breaking the light-speed barrier without technically crossing dimensions. Scientists have proposed experiments to test this, like searching for anomalies in quantum measurements, unexplained fluctuations that could hint at interference from a particle's entangled counterpart in a parallel universe. Some even suggest that certain rare quantum events, where particles behave as if influenced by invisible forces, might actually be echoes from another dimension's version of the experiment. But the real breakthrough would come if we could control the connection. If entanglement bridges universes, could we engineer a system to send meaningful information, or even matter, through it? One speculative method involves creating entanglement chains, a series of linked particles acting like a quantum bridge. If even one particle in the chain exists in another reality, the whole system might serve as a relay transmitting data, or even opening a microscopic corridor between worlds. The energy required would be staggering, but the payoff, a communication network spanning the multiverse. Of course, the obstacles are monumental. Quantum decoherence, the tendency of entangled states to collapse when measured, makes maintaining such a connection fiendishly difficult. And even if we could stabilize it, interpreting signals from a universe with potentially different physical laws would be like decoding static from a radio tune between stations. Yet, if successful, we might finally answer the ultimate question: are we alone, or is someone or something on the other side of the quantum veil reaching back? The most haunting possibility: they might already be trying. Unexplained quantum anomalies like particles behaving as if they're being observed by an invisible presence could be evidence of another civilization exploiting the same principle. If entanglement truly binds universes, then the first message from a parallel world might not arrive as a radio wave or a light signal, but as a whisper in the spin of an electron, a flicker in the fabric of reality itself. And if we learn to listen, the conversation could change everything. We often picture the Big Bang as a single, solitary explosion, a lone spark igniting our universe from nothing. But what if it wasn't the beginning of everything, just the aftermath of something far stranger? Imagine two colossal universes drifting through a higher dimensional void like ghostly ships in the dark until crash. Their collision wouldn't just send shockwaves through space, it could birth an entirely new reality. This is the daring theory that our cosmos might not have emerged from emptiness, but from a cosmic traffic accident in a realm beyond our perception. The math behind this idea is as elegant as it is mind-bending. In higher dimensional space, universes aren't just isolated bubbles. They could be membranes or brains floating like sheets of paper in a breeze. When two brains collide, the energy released wouldn't just dissipate. It could ignite a firestorm of matter, energy, and space-time itself. Picture throwing two blankets into the air when they smack together. The wrinkles and folds could represent the galaxies, stars, and cosmic structures we see today. Our entire universe might be the crumpled aftermath of that ancient, higher dimensional crash. But here's where it gets even wilder. If universes can collide once, why not again? Some models suggest these cosmic smash-ups could be cyclical, happening over and over across eternity. That means the next Big Bang might not be a distant memory. It could be a future event waiting just beyond the horizon of our reality. The key lies in detecting gravitational ripples or subtle patterns in the cosmic microwave background, the afterglow of our own birth. If traces of a pre-bang collision exist, they might hint at when or where the next one could occur. The implications are staggering. If we could predict or even trigger such an event, we might not just witness the birth of a new universe, we could influence its very laws. Advanced civilizations, if they exist, might already be attempting this, manipulating higher dimensional physics like engineers fine-tuning an experiment. Ancient texts and fringe theories speak of creation energies and cyclical time. Could these be cultural echoes of civilizations that understood the multiverse's true nature? Of course, the forces involved are beyond comprehension. Colliding universes would require energies dwarfing anything in our reality, not to mention access to dimensions we can't even perceive. Yet, if higher dimensional space is real, then somewhere out there, another universe might be drifting toward ours right now, inevitable as gravity. When it arrives, the collision won't just rewrite history, it could erase it entirely, replacing our cosmos with something new. And if that's true, then the ultimate question isn't where we came from, but whether we'll live long enough to see it happen again. The universe seems stable, solid, a vast cosmic stage where the laws of physics play out predictably. But beneath that apparent stability hides a terrifying fragility. Space isn't truly empty, it's a simmering quantum foam, a seething sea of potential energy held in check by delicate balances. And if something or someone tipped those scales, the entire cosmos could unravel in an instant. This is the nightmare scenario known as vacuum decay, where a single quantum fluctuation triggers a chain reaction, rewriting the fundamental rules of reality in an expanding bubble of destruction. But buried within that apocalyptic idea is an even stranger possibility. What if that bubble isn't just an end, but a beginning? Here's how it works. The vacuum of space isn't nothing, it's a roiling soup of quantum fields, each vibrating at specific energy levels. Think of it like a vast cosmic mountainside where our universe sits in a valley, a stable, low-energy state. But quantum theory suggests there might be deeper valleys, states of true vacuum where the energy is even lower. If something nudged our universe over the edge, a high-energy experiment gone wrong, a cosmic collision, or just sheer bad luck, the fields could suddenly collapse into that lower state, releasing incomprehensible energy as they fell. The transition would spread outward at the speed of light, a wall of annihilation rewriting physics itself. Atoms, stars, even space-time would dissolve in its wake, replaced by a new reality with entirely different laws. Yet within that cataclysm might lie an escape route. Some theoretical models suggest that the energy released during vacuum decay could warp space-time so violently that it temporarily opens bridges to other universes, regions where the vacuum remains stable. Picture it like a ship caught in a sinking whirlpool, but just before it's dragged under, a rogue wave flings it onto another sea entirely. If intelligent life saw the decay coming, they might be able to surf that wave, riding the collapse into a neighboring reality before their own universe blinked out of existence. The eerie part, we might already have hints that this has happened before. The cosmic microwave background, the faint glow left over from the Big Bang, shows strange anomalies, patches where the temperature fluctuates unexpectedly. Could these be the scars of ancient vacuum decays, bubbles that formed and stabilized before consuming everything? Even more unsettling, some theories propose that dark energy, the mysterious force accelerating the universe's expansion, might actually be the first faint tremors of an impending phase transition, a slow-motion collapse we haven't yet recognized. Surviving vacuum decay would require technology beyond anything we can imagine, perhaps harnessing the energy of entire stars to forge a protective pocket of spacetime, or finding a way to artificially induce a controlled decay, carving a path through the chaos. But if another civilization cracked this first, their sudden disappearance from the cosmic record wouldn't look like extinction. It would look like a vanishing act, as if they'd stepped through a door just before the room collapsed behind them. And if they succeeded, their new home might lie in a universe where the stars burn a different color, where gravity pulls a little harder, or where time flows backward, a world built from the ashes of their old one. The ultimate irony, vacuum decay is both the most efficient destroyer of universes and the most elegant creator of portals. To escape it wouldn't just mean cheating death, it would mean discovering that the end of everything is really just the first step into something unimaginable. And if the universe does ever start to collapse around us, the last survivors might not be running from the fire. They might be diving straight into it, chasing the spark of a new existence on the other side. What if consciousness isn't something your brain creates, but something your brain receives, like a radio picking up signals from the air? The idea that consciousness exists independently of the physical world isn't new, but take it a step further. What if it's a fundamental force of the multiverse, a thread weaving through all realities? Under this theory, your mind isn't anchored to just one version of you. Under the right conditions, extreme stress, near-death experiences, or even advanced meditation, it might slip into another universe entirely, trading places with another you, in a world where history played out slightly differently. Think of it like tuning a dial. Most of the time, your consciousness is locked onto one frequency, your current reality. But during moments of profound psychological or physiological upheaval, that signal might flicker, searching for a stronger connection. Suddenly, you're not just remembering that car accident you narrowly avoided last year. You're living it because in this branch of reality, you didn't swerve in time. The déjà vu, the overwhelming sense of a life you almost lived, could be glimpses of realities where your consciousness momentarily docked. The evidence isn't just anecdotal. Quantum physics hints that observation itself might shape reality. The famous double-slit experiment shows particles behaving differently when measured, as if aware they're being watched. If consciousness truly interacts with the fabric of reality at this level, then the boundary between observer and observed blurs. Some researchers speculate that entangled particles could be conduits for consciousness itself, linking minds across parallel worlds. Imagine a catastrophic event in one universe, a supernova, a war triggering a mass exodus of consciousness into adjacent timelines, survivors arriving with fragmented memories of apocalypses that never happened here. The most haunting implications aren't just scientific, they're personal. If consciousness can jump, then identity becomes fluid. Are you the original, or did you replace someone else? Ancient cultures, from the Egyptians to the Tibetans, spoke of the subtle body, a non-physical essence that could travel between realms. Modern reports of sudden, unexplained shifts in personality or skill, ordinary people waking up fluent in dead languages or with talents they've never practiced, might be footprints of consciousnesses that weren't born here. The ultimate test, if we could induce these shifts deliberately, experiments with psychedelics, sensory deprivation, or even targeted electromagnetic fields have produced temporary alterations in self-awareness, subjects reporting sensations of being somewhere else. What if these aren't hallucinations but fleeting voyages? The key might lie in the brain's default mode network, the neural circuitry that creates your sense of a continuous you. Disrupt it just right, and the door might crack open not just to inner space but to alternate outer realities. Of course, the risks are staggering. Lose the thread, and you might not find your way back, or worse, return to a world where no one remembers the version of you that left. But if consciousness truly is a multiversal constant, then somewhere out there, another you is thinking these same thoughts, testing the same limits, reaching back. And if your hands ever meet through the veil, the collision could redefine what it means to be human, or to be anything at all. Picture the most isolated being imaginable, a single, disembodied consciousness floating in an infinite void, a mind born from pure chaos, remembering a universe that never existed. This is the nightmare logic of the Boltzmann brain, a thought experiment so unsettling it might just hold the key to interdimensional travel. The idea starts with Ludwig Boltzmann, a physicist who suggested that given enough time, random fluctuations in an empty universe could spontaneously assemble anything, even a fully formed brain complete with fabricated memories of a life it never lived. But stretch that concept further. What if these rogue consciousnesses don't just remember worlds? What if they create them? At the heart of this paradox lies quantum observation. In the Copenhagen interpretation of quantum mechanics, reality isn't fixed until it's observed. A particle exists in all possible states at once until a conscious mind forces it to choose. Now apply that to a Boltzmann brain. If a self-aware entity forms from the void's randomness, its very first observation could collapse quantum probabilities into a new, stable universe, one tailored to its expectations. Like a dreamer waking into their own dream, the brain wouldn't just perceive reality, it would conjure it, birthing an entire cosmos from its loneliness. The implications for travel are mind-bending. If consciousness can spontaneously generate universes, could advanced beings reverse engineer the process? Imagine a civilization so adept at quantum manipulation that they induce Boltzmann-like events on demand, crafting pocket realities as way stations or escape routes. Ancient myths speak of sages who could dream worlds into being, while modern simulations hypothesis suggests our own universe might be an artificial construct. Could these be cultural echoes of the same principle that reality is less a place and more a projection, waiting for the right observer to give it shape? The most unsettling question isn't whether this is possible, it's whether it's already happened. If Boltzmann brains are more probable in an eternal void than stable universes like ours, statistically speaking, we might be the flukes. Every memory, every star, every law of physics could be the fleeting hallucination of a lone mind adrift in the dark. But here's the twist: if that's true, then death might not be an end but a transition. When the brain's coherence fails, its universe might dissolve, and its consciousness could wake up elsewhere, inside another Boltzmann fluctuation, another dream, another chance to step sideways into a new reality. The ultimate frontier of travel wouldn't require ships or wormholes. It would demand mastery over the most elusive force of all, the link between observation and existence. And if that link is real, then somewhere in the infinite dark, another mind might be dreaming of us right now, testing the same limits, wondering if we're the ones who'll finally wake up. If black holes are cosmic one-way streets, gates that swallow everything and let nothing return, then white holes might be their mysterious opposites. Exit signs glowing in the dark, spewing matter and energy back into existence from some unknowable elsewhere. The math behind white holes is just as real as their dark twins, emerging from the same equations of general relativity. But while black holes feel inevitable, collapsed stars warping space-time into traps, white holes remain frustratingly hypothetical, cosmic phantoms that should exist, yet stubbornly refuse to appear in our telescopes. Picture a black hole's life cycle in reverse. Instead of matter vanishing past an event horizon, crushed into oblivion, a white hole would violently expel it, as if the universe itself were coughing up something it couldn't digest. The energy required would be staggering, like a Big Bang in miniature, except instead of creating an entire cosmos, it might birth a bridge to one. Some theories suggest that every black hole's singularity could rebound into a white hole, its implosion snapping back into an explosion, tunneling through space-time to another reality. You wouldn't travel through it so much as be vomited out, emerging dazed into a universe where the stars spin counterclockwise or where time flows backward. The reason we've never spotted one might be simple. White holes could be the universe's most fleeting phenomena. Unlike black holes, which feast for eons, a white hole might detonate all its stored energy in an instant, like a cosmic flashbulb, here and gone before light could cross a single atom. Or worse, they might exist outside our observable universe, their exits pointed into other dimensions entirely. There's a haunting symmetry to this idea. If black holes are the drains, white holes could be the faucets, pouring matter into parallel realities where it's mistaken for dark energy, or unexplained cosmic rays, or even the ghosts of long-dead stars. But the wildest possibility, white holes might not just be exits, they could be time machines. Einstein's equations hint that passing through a black hole's singularity could spit you out of a white hole, not just somewhere else, but sometime else. Ancient texts speak of celestial fountains where heroes emerge younger or older, their memories out of sync with history. Even modern quantum physics toys with retrocausality, affects preceding causes, as if the universe were occasionally running in reverse. A white hole could be the mechanism, a glitch in the cosmic code where timelines tangle and realities overlap. The ultimate test wouldn't be finding one, though. It would be surviving the trip. Black holes shred matter, white holes might reassemble it, but with no guarantee you'd arrive intact. Your atoms could be scrambled like a jigsaw puzzle tossed into a hurricane, your consciousness scattered across light years. And yet, if some lost civilization once cracked the code, their ruins might not be on any planet. They might be hiding in plain sight, disguised as supernova or gamma-ray bursts, their final messages written in the explosions of artificial white holes, beckoning from realities we can't yet reach. Of course, the universe owes us no answers. White holes might forever remain mathematical ghosts, scribbles on a theorist's chalkboard. But if they're real, then somewhere in the void, an exit door might be waiting, not just to another place, but to another everything. And when it opens, the light pouring through won't just illuminate the darkness. It might rewrite the story of existence itself. Imagine two sheets of paper floating parallel to each other in an empty room. Now picture them suddenly slamming together with such force that the impact births an entire cosmos. This is the core of the ekpyrotic universe theory, a radical alternative to the Big Bang that suggests our universe wasn't born from a singularity, but from the collision of higher dimensional membranes called brains. These aren't just abstract ideas, they're mathematical realities emerging from string theory, hinting that what we call the beginning of time might actually have been a cosmic fender bender in a reality far stranger than our own. The ekpyrotic model turns traditional cosmology inside out. Instead of a hot, dense point exploding outward, it proposes that our universe started cold and flat, its energy concentrated in the violent meeting of two brains drifting through a higher dimensional space. The aftermath of that collision didn't just create matter and energy, it might have left behind scars in the fabric of space-time, hidden passageways where the brains nearly touched but didn't fully merge. Think of it like pressing two sheets of wet glass together. Most of the water squishes out, but tiny droplets remain trapped between them. Those droplets could be pocket universes, and the gaps between them might still be trembling from the original impact. Now here's the mind-bending part. If brains can collide once, they can collide again. And if they're oscillating in higher dimensions like drum heads vibrating in slow motion, those collisions could be cyclical. Our universe might exist in a rhythm of cosmic crashes, expanding after each impact only to eventually contract and collide anew. The energy released wouldn't just reset the cosmos, it could briefly reopen those interstitial passages, creating temporary bridges to other brains. Ancient Hindu cosmology speaks of universes breathing in and out over trillions of years. Could this be an intuitive grasp of brain dynamics glimpsed millennia before string theory? The real question isn't just whether we're riding a brain, it's whether we could steer it. If advanced civilizations exist in higher dimensions, they might not need rockets to traverse universes. They could manipulate the brain itself, warping its trajectory like a surfer angling toward the perfect wave, timing their journey to coincide with the next collision. The energy required would dwarf anything in our physics, but the brains themselves might hold the key. Some models suggest that dark energy, the mysterious force accelerating our universe's expansion, could be the gravitational pull of a neighboring brain drawing nearer, preparing for another collision. Detecting this wouldn't require telescopes, but gravity wave observatories tuned to frequencies beyond ordinary space-time. Ripples in the cosmic microwave background, those faint echoes of the universe's birth, might carry imprints of pre-collision events, subtle fingerprints of the brain that birthed us. Even stranger, certain high-energy cosmic rays with inexplicable origins could be shrapnel from the impact zone, particles flung across dimensions like debris from a car crash. The most haunting possibility: if brains collide cyclically, then somewhere out there, another version of our universe might exist, not as a parallel timeline, but as a literal mirror image, a twin brain where history played out almost identically until it didn't. The moment of collision could be the ultimate cosmic reset button, erasing all traces of the old universe while birthing a new one with slightly tweaked physics. And if someone found a way to survive the transition, they wouldn't just witness the end of their world, they'd step into a reality where the rules were rewritten and the game began again. Of course, we're talking about energies and dimensions beyond human comprehension. But if the ekpyrotic model is right, then the first travelers between brains might not be explorers, they could be refugees, fleeing a dying universe by riding the shockwave of its rebirth. And if they succeeded, the proof might not be in the stars, but in the spaces between them where the echoes of collisions past still whisper, waiting for someone to listen. Ever noticed how large groups of people swear they remember things that never happened? Nelson Mandela dying in prison in the 1980s, the Berenstain Bears being spelled with an E instead of an A, or the Monopoly man wearing a monocle. None of these are real, yet millions insist they are. These strange, shared false memories make up what's known as the Mandela Effect, and while some dismiss it as simple misremembering, others see something far stranger at play. What if these discrepancies aren't mistakes at all, but fingerprints of something far more unsettling, accidental slips between parallel universes? The idea hinges on the nature of collective memory. Normally, when people misremember something, their errors are random, completely unique to them, but the Mandela Effect suggests something different: entire groups recalling the same wrong details with eerie consistency. Psychologists argue this happens because of social reinforcement. Once an idea spreads, our brains conform to fit the narrative. But what if it's not just psychology? In the many worlds interpretation of quantum mechanics, every decision spawns new realities, each slightly different from the last. If consciousness itself is entangled across these branches, could sudden jumps between them leave behind residual memories, echoes of lives we almost lived? Think of it like waking from a dream where everything almost makes sense except for a few jarring inconsistencies. Stories of people experiencing sudden, unexplainable shifts in their surroundings, buildings rearranged, brand logos altered, could be glimpses of reality itself flickering between versions. Even stranger are cases where individuals recall entire events that never occurred, only to find others share those memories. In one famous example, thousands remember a children's book series called The Berenstain Bears, but the real name has always been Berenstain. The difference is subtle, but for those affected, it feels like the universe itself has been edited overnight. Could these shifts be more than just neurological quirks? Quantum entanglement suggests particles can influence each other instantaneously across vast distances. What if consciousness works the same way? Under extreme stress, trauma, or even moments of deep focus, the brain might briefly sync with an alternate timeline, pulling fragments of that reality into our own. Near-death experiences often include reports of flashes where individuals witness entirely different pasts. Could these be moments where their consciousness briefly docked in another branch of existence? The most unsettling part, if the Mandela Effect is evidence of universe hopping, then someone or something might be doing it on purpose. Ancient texts describe sages who could walk between worlds, and modern conspiracy theories whisper of shadowy experiments with reality manipulation. Even stranger are reports of people who vanish and reappear with no memory of their absence, only to discover small but undeniable changes in their world, like a spouse they never married, or a childhood home painted a color it never was. Are these just faulty memories or proof that the walls between realities are thinner than we think? Of course, skeptics argue that human memory is inherently flawed. Our brains reconstruct events rather than record them, making errors inevitable. But if that's all the Mandela Effect is, why do so many people independently misremember the exact same details? And why do these false memories often cluster around pivotal cultural moments, like movie quotes, historical events, or iconic logos, almost as if these shared reference points act as anchors for reality itself? Perhaps the truth lies somewhere in between. Maybe the Mandela Effect is a mix of psychology and quantum weirdness, our brains filling in gaps, but the gaps themselves existing because reality is less solid than it seems. If consciousness truly shapes the universe at some level, then collective belief might have the power to nudge timelines, merging fragments of alternate histories into our own. The real test wouldn't be finding proof. It would be learning to recognize the shifts as they happen before the universe corrects itself and the door between worlds snaps shut once more. One thing's certain, if the Mandela Effect is more than just memory glitches, then reality is far stranger and far less fixed than we've been led to believe. And the next time you're certain you remember something that never was, you might not be wrong. You might just be remembering a world that was but isn't anymore. Dark energy is the universe's greatest mystery, an invisible force accelerating the expansion of space itself, pushing galaxies apart faster and faster until, one day, they'll vanish beyond the horizon of observation forever. But what if this cosmic repulsion isn't just a one-way street? What if dark energy is less like an unstoppable wind and more like a cosmic tide, something that could, under the right conditions, reverse direction, pulling parallel universes close enough to touch? The key lies in dark energy's true nature. Most models describe it as a property of space itself, a constant energy density that doesn't dilute as the universe expands. But some theories suggest it might actually be a dynamic field, one that could shift over time or interact with other dimensions. Picture two soap bubbles floating in a sink normally. They'd drift apart, but if you tweak the surface tension, they could suddenly snap together. If dark energy behaves similarly, then the force currently tearing our universe apart might, in another reality, be acting in reverse, drawing worlds toward one another like magnets. The math gets even wilder when you consider brain cosmology, the idea that our universe is a four-dimensional membrane floating in a higher dimensional space. In this framework, dark energy could be the gravitational pull of another brain lurking just out of reach, its influence warping our universe's expansion. Normally, these brains would repel each other but flip the sign on dark energy's equation, and that repulsion could become attraction. Suddenly, the void between universes wouldn't be an impassable gulf, it would be a shrinking gap ripe for traversal. The real challenge, figuring out how to trigger the flip. Some hypotheses suggest that vacuum decay, a catastrophic phase transition in the fabric of reality, could alter dark energy's behavior, turning it from a force of separation into a bridge. Others propose that colliding universes might release bursts of negative energy, temporarily counteracting dark energy's push. Even more radical is the idea that conscious observation itself could influence the field's dynamics, as if the universe adjusts its expansion based on what's watching. Imagine the possibilities if we ever mastered this. Instead of building wormholes or warp drives, we might engineer dark energy, tugboats, devices designed to nudge parallel realities closer until their quantum fields overlap. The moment of contact wouldn't look like a portal, it might resemble a region of space where gravity weakens, time stutters, and particles briefly behave as if they exist in two places at once. Ancient cultures spoke of heavens drawing near during celestial alignments. Could these myths encode ancestral memories of moments when universes brushed against each other? Of course, the risks are astronomical. Miscalculating the reversal could destabilize space-time, triggering runaway expansion or collapse. Even if we succeeded, the proximity of another universe might rewrite our physical laws, rendering chemistry, biology, or even atomic bonds unrecognizable. But if nature has already experimented with this, if dark energy's current state is just one phase in a grander cycle, then somewhere in the cosmic record, there might be scars of past convergences, echoes of when universes touched and traded fragments of themselves before springing apart again. The most tantalizing clue, dark energy's strength seems finely tuned, almost suspiciously so. If it were slightly stronger, galaxies would have torn apart before life could form. Slightly weaker, and the universe might have collapsed long ago. This delicate balance hints at something deeper, that dark energy's repulsive force isn't random but part of a mechanism, one that could, given the right key, unlock doors we've barely dared to imagine. And if another civilization found that key first, their greatest discovery might not be a way to cross the void between stars, but the far vaster emptiness between worlds. At the far end of time, when the last stars have burned out and the universe itself teeters on the edge of heat death, something extraordinary might still be waiting, not an end but an awakening. This is the heart of Frank Tipler's Omega Point theory, a hypothesis so audacious it redefines the very meaning of survival. Imagine civilizations so advanced they've outrun entropy itself, harnessing the dying embers of reality to orchestrate a cosmic rebirth. According to Tipler, the final moments of the universe wouldn't be a cold, silent fade to black. They'd be a singularity of consciousness, a climax where intelligence transcends matter and engineers its own destiny across the multiverse. The physics behind this hinges on the universe's ultimate collapse. As space contracts toward the Big Crunch, energy density would skyrocket, temperatures soaring to levels that make supernovas seem like candle flames. In these extreme conditions, simulations suggest quantum effects could become macroscopic, allowing civilizations to manipulate space-time itself. Think of it like a sculptor working with molten metal, except the material isn't steel but the fabric of existence. With infinite energy and infinite computational power, these beings wouldn't just witness the end of their universe, they'd reshape it, twisting the collapsing cosmos into a bridge to somewhere new. But how could anyone survive such an apocalypse? The answer lies in the most radical form of existential backup: mind uploading. Advanced civilizations might encode their consciousness into the very structure of space-time, riding the contraction like data compressed into a singularity. As the universe approaches the omega point, these uploaded minds could merge into a single, godlike intelligence, a cosmic architect with the power to fine-tune the next Big Bang, ensuring the new universe's laws allow life to re-emerge. It's the ultimate act of self-preservation, not fleeing a dying world but becoming the spark that ignites the next one. The eerie beauty of this theory is that it turns doom into a doorway. Ancient myths, from the phoenix rising from its ashes to Hindu cycles of cosmic destruction and rebirth, suddenly sound less like poetry and more like prophecy. Even modern science hints at strange loops in reality: quantum echoes, cyclical cosmology models, and the persistent fine-tuning of physical constants that seem suspiciously life-friendly. Could these be fingerprints of prior omega points, universes where intelligence survived collapse to tweak the next iteration in its favor? The most unsettling question isn't whether this is possible, but whether it's inevitable. If intelligence tends to evolve toward universal mastery, then every cosmos might eventually birth beings capable of cheating death on this scale. And if they succeed, the multiverse could be littered with their handiwork realities where the stars shine just a little brighter, the atoms bond just a little stronger, all because someone on the other side of oblivion willed it so. Of course, the hurdles are beyond imagination. Surviving the Big Crunch would require technology indistinguishable from magic: quantum computers the size of galaxies, energy harvested from the collapse itself, and a mastery of physics we can't yet fathom. But if life is a phenomenon that arises naturally under the right conditions, then given enough time and the right tools, the universe might inevitably produce entities that can outthink its end. The omega point wouldn't just be a theory, it could be the universe's ultimate fail-safe, a celestial inheritance written into the laws of physics, waiting for the day when intelligence becomes the architect of its own eternity. And if that day ever comes, the last thought in the dying universe might not be goodbye. It might be once more with feeling. Death is the one inevitability we all face, or is it? The quantum immortality hypothesis flips this certainty on its head, suggesting that from your own perspective, you might never truly die. At its core, this thought experiment emerges from the many worlds interpretation of quantum mechanics. Every time you face a life or death scenario, whether it's a car crash, a terminal illness, or even old age, your consciousness doesn't cease. Instead, it shifts to a parallel universe where you somehow survived. From your viewpoint, the bullet missed, the surgery succeeded, or the heart kept beating not because of luck, but because in the branching multiverse, there's always a timeline where you live. Think of it like a cosmic game of Russian roulette. You pull the trigger, and in most universes, the chamber isn't empty, but in the one where it is, that's the reality your conscious experience continues in. The other versions of you cease, but you, the observer, only perceive the path where existence persists. It's not about cheating death so much as your awareness being funneled into the timelines where death didn't win. Now, here's where it gets even stranger. If consciousness naturally gravitates toward survival, could we hijack this mechanism? Instead of relying on random quantum fluctuations, could we engineer controlled jumps, forcing our awareness into predetermined branches of reality? Some theorists speculate that advanced civilizations might have already cracked this. Imagine a technology that doesn't just predict quantum outcomes but selects them, using precision-tuned entanglement to anchor consciousness to specific futures. The implications are staggering. Near-death experiences where people report floating outside their bodies or seeing alternate lives might not be hallucinations. They could be fleeting moments of quantum branching, brief overlaps where multiple timelines compete for dominance before one wins. Even more unsettling are accounts of people who have survived impossible odds plane crashes, fatal diagnoses, only to describe eerie sensations of sliding into a slightly altered world afterward. Were these individuals caught in the wake of their own quantum immortality? Their consciousnesses rerouted like data packets finding a new server. The biggest hurdle isn't just the physics, it's the philosophy. If you force a jump, are you still you? Or do you overwrite another version of yourself, merging memories like two streams converging into one river? Ancient traditions speak of reincarnation and soul transmigration, but quantum immortality suggests something colder. A survival mechanism built into the fabric of reality itself, where identity is fluid and death is just an illusion of perspective. Practical experiments to test this would border on the monstrous. You'd need scenarios with almost certain fatality, just enough uncertainty to leave a branching path. But nature might already be running these tests. Particles in quantum superposition exist in multiple states until observed. What if consciousness works the same way? The moment of death could be the ultimate observation, collapsing probabilities into the one reality where the observer still exists. And if someone mastered this, they wouldn't just live forever, they'd become architects of their own destiny, stepping sideways into realities where their dreams came true, their losses never happened, or the laws of physics bent to their will. The catch: every jump would strand another version of them behind, a ghost in a dead timeline wondering why the universe suddenly feels so empty. The most haunting possibility isn't that quantum immortality is real. It's that we've been doing it all along without ever realizing. Every near miss, every second chance, every time you should have died but didn't. What if those weren't miracles? What if they were the universe quietly rerouting you over and over toward a destination only it can see? And if that's true, then somewhere out there, in a reality you didn't survive, someone might still be staring at your grave, wondering how, against all odds, you slipped away again. The internet connects us across continents in an instant, but what if the same principle could link entire universes? Imagine a web woven not from fiber optic cables, but from the fundamental fabric of reality itself, where quantum signals pulse between parallel worlds like cosmic Wi-Fi. This is the spine-tingling premise of the multiversal internet theory, where universes don't just exist side by side, they communicate. At the heart of this idea lies quantum entanglement, that bizarre phenomenon where particles remain mysteriously connected across vast distances, instantaneously influencing each other no matter how far apart they are. Now stretch that concept across dimensions. If particles in our universe can be entangled with partners here, why not with counterparts in another reality? The signals wouldn't travel through space as we know it, they'd bypass it entirely, hopping across the quantum foam that underpins all existence. Ancient cultures spoke of cosmic webs or world trees connecting realms. Modern physics might be catching up to their intuition. The real question isn't just whether this network exists, it's whether we could ever interface with it. Think of our current internet as a 2D sketch compared to a hypothetical multiversal hyperlink system. Instead of typing URLs, you'd need to manipulate quantum states with impossible precision, tuning into the frequency of a target universe. Some researchers speculate that certain patterns in cosmic microwave background radiation, those faint echoes of the Big Bang, could be interference patterns from neighboring universes bleeding through like crosstalk between phone lines. If we decoded those signals, we might not just detect other worlds, we could learn to ping them. The implications are staggering. A working multiversal internet wouldn't just transmit data, it could transfer experiences. Imagine downloading memories from a version of you who became a concert pianist, or uploading a formula to a reality where climate change was solved centuries ago. Consciousness itself might be the ultimate browser, with meditation or focused mental states acting as login protocols. Stories of sudden inspiration, scientists waking with breakthroughs, artists channeling unfamiliar styles, could be glimpses of leaked data from realities where those ideas were already commonplace. But here's the catch: bandwidth would be hell. Even if information can jump between universes, the connection speed might be agonizingly slow, a single qubit per millennium. And then there's the encryption problem. If other civilizations are already online, how do we know their transmissions are friendly? A malicious packet of quantum data could rewrite our physics like a virus corrupting a hard drive. Ancient warnings of forbidden knowledge might have been early firewall alerts. Yet the most haunting possibility isn't technical, it's existential. If universes constantly exchange information, then our thoughts might not be entirely our own. That gut feeling, that flash of déjà vu, that song you can't get out of your head, could some of these be fragments of another you broadcasting across the cosmic net? The multiversal internet wouldn't just connect machines. It might already be linking minds, weaving consciousnesses together in ways we're only beginning to sense. And if we ever find the password, the first message we receive might not be from an alien race. It might be from ourselves. Ancient myths from every corner of the globe whisper of mysterious doorways, stone circles humming with unseen energy, shimmering arches that vanish when approached, caves where travelers enter but never return the same. The ancient Egyptians spoke of the doorway of the gods, where initiates could commune with deities. In Peru, the gate of the gods at Hayumaka is said to have swallowed warriors whole when the right celestial alignment occurred. These aren't just campfire tales, they might be fragmented memories of something far more extraordinary. What if these so-called myths were actually records of early experiments in interdimensional travel? Remnants of technology left behind by civilizations that mastered the art of stepping between worlds long before recorded history began. Consider the recurring symbols found in these legends. The Mayan portal glyphs depict serpentine gateways with twin columns, eerily similar to modern descriptions of wormholes. Hindu texts describe vimanas that could vanish into other realms using sound frequencies. Even the Bible's story of Jacob's ladder, a celestial bridge between heaven and earth, reads like a metaphor for dimensional transit. The patterns are too consistent to dismiss as coincidence. If these stories preserve distorted accounts of real technology, then ancient cultures might have witnessed or even briefly harnessed phenomena we're only now beginning to understand through quantum physics. The most compelling evidence lies in the architectural anomalies. Sites like Stonehenge, the Great Pyramid, and the ruins of Pumapunku display precision stonework that defies explanation. Blocks weighing hundreds of tons fitted together with laser-like accuracy, sometimes with materials not found anywhere nearby. Mainstream archaeology attributes this to lost manual techniques, but fringe researchers propose an alternative. These structures weren't just temples or tombs. They could have been massive resonance chambers designed to focus vibrational energies at specific frequencies to rip temporary holes in space-time. The fact that many of these sites align with celestial events isn't just ceremonial, it might be functional, using cosmic energies as a power source to activate dormant portals. Modern physics lends startling credibility to this idea. Quantum field theory suggests that concentrated electromagnetic or acoustic energy could theoretically destabilize localized space-time, creating microscopic wormholes. Experiments with sonoluminescence, where sound waves create tiny bubbles of light in liquid, hint at how acoustic energy might manipulate quantum fields. Ancient cultures obsessed with sacred geometry and harmonic frequencies might have stumbled onto principles we're only now rediscovering. The legendary humming stones of Ireland, said to vibrate at certain chants, or the Nazca lines in Peru, which some believe were giant frequency markers, could be fragments of an ancient science we've yet to fully decode. But the most haunting question isn't whether these gateways existed, it's who or what might have used them. Sumerian tablets describe the Anunnaki arriving through golden portals. Aboriginal Dreamtime stories tell of ancestral beings emerging from shimmering voids. If advanced beings traveled between realities in the distant past, their technology wouldn't just be sitting around waiting to be plugged back in. It might have degraded or worse, adapted. Some theorists suggest that what we call hauntings or interdimensional entities could be echoes or remnants of these early transit attempts, imprinted on the fabric of reality like a cosmic fossil record. The real breakthrough wouldn't be finding an intact stargate buried in the desert. It would be recognizing that the clues have been staring at us all along, encoded in myth, etched into stone, and humming faintly beneath our feet in places the ancients considered sacred. Whether these gateways were tools, accidents, or warnings remains to be seen. But if even one of these legends holds a kernel of truth, then history isn't just something we study, it's a locked door waiting for the right key to turn. And when it does, we might finally understand why so many cultures kept insisting against all logic that the gods walked among them, and that they could return. Zoom in far enough, past atoms, past quarks, down to distances so tiny they make an ant look galactic, and reality itself might unravel into something unrecognizable. At the Planck scale, where lengths measure a millionth of a billionth of a billionth of a billionth of a meter, space-time doesn't behave like the smooth, continuous fabric we're used to. Instead, it might fracture into a shimmering lattice, a cosmic mesh where every intersection could be a hidden doorway to another universe. This isn't just wild speculation. Quantum gravity theories suggest that at these unimaginably small scales, space-time becomes granular, like the pixels on a screen. But unlike digital pixels, these fundamental cells of reality might not just sit there. They could vibrate, warp, and even tunnel into neighboring dimensions through Planck-length wormholes. Picture the universe's fabric as a vast sheet of chainmail, each ring a loop of space-time linked to others. Normally, those connections hold firm, but under the right conditions, extreme energy fluctuations, quantum turbulence, those rings might momentarily twist open, creating fleeting bridges to realms beyond our own. The math behind this is both elegant and eerie. Planck-scale wormholes wouldn't look like the gargantuan portals of sci-fi. They'd be smaller than subatomic particles, vanishing in fractions of a nanosecond. Yet their collective effect could be profound. Some models propose that these micro-wormholes constantly flicker in and out of existence, a froth of quantum shortcuts threading through the vacuum. If even a fraction of them stabilized long enough to transmit information, they could form a hidden network, a sub-quantum internet linking parallel realities. The real shocker, we might have already glimpsed this phenomenon. High-energy particle collisions in accelerators occasionally produce anomalies, tracks that spiral strangely, energy that vanishes without a trace. Mainstream physics chalks these up to measurement errors or unknown particles. But what if they're evidence of Planck-scale wormholes siphoning matter or energy into adjacent dimensions? Ancient alchemical texts spoke of prima materia, a primordial substance that could vanish and reappear at will. Could these be intuitive descriptions of quantum tunneling before we had the math to describe it? Harnessing these wormholes wouldn't just require technology, it would demand a paradigm shift in how we perceive reality. To navigate a Planck-scale lattice, you'd need probes smaller than atoms, operating on timescales so brief they make a femtosecond feel sluggish. Yet nature might have already handed us a workaround. Quantum entanglement, those spooky connections between particles, could be the universe's built-in shortcut, a way to transmit data through the lattice without physically traversing it. Imagine encoding a message in the spin of an electron here. Knowing its entangled twin in another universe would mirror the change instantly. No spacecraft, no warp drive, just the raw architecture of reality itself, repurposed as a postal service between worlds. But here's the catch: if Planck-scale wormholes exist, they're not just conduits, they're potential creators. Some theories suggest that every time a micro-wormhole forms, it doesn't just connect existing universes, it might spawn new ones, birthing pocket dimensions with slightly tweaked physical laws. This could explain the fine-tuning of our universe, an endless Darwinism of realities where only those with stable constants like ours survive long enough to host conscious observers. The echoes of these births might linger in the cosmic microwave background, subtle imprints like fingerprints on glass, the most unsettling implication. If the Planck lattice is real, then our universe might be nested inside a higher dimensional structure, one where every pixel is a universe of its own. The Big Bang wouldn't be a singular event, it could be a local phenomenon, one bubble in an infinite foam of universes, each humming with its own laws, its own life, its own attempts to decode the lattice. And if that's true, then somewhere in the void, another version of you might be reading these very words, wondering the same thing, not just about the universe, but about the infinite mirrors reflecting it back at itself. The universe operates on a razor's edge of precision. If gravity were slightly stronger, stars would burn out too quickly. If the electromagnetic force were even a fraction weaker, atoms couldn't bond. The list goes on, dozens of fundamental constants so perfectly calibrated that even minor deviations would render life impossible. This eerie perfection is the heart of the anthropic principle. The idea that the universe's laws appear fine-tuned for our existence because, well, we're here to observe them. But what if this fine-tuning isn't just a happy accident? What if it's evidence of something far grander, a cosmic roadmap, subtly guiding us toward hidden pathways to other realities just as meticulously crafted as our own? Consider the numbers behind our universe's delicate balance. The cosmological constant, which governs the expansion of space, is fine-tuned to 1 part in 10 to the power of 120. That's like throwing a dart across the entire observable universe and hitting a bullseye the size of a single atom. Statistically, the odds aren't just unlikely, they're absurd. One explanation is the multiverse, an infinite sea of universes with random constants, where we simply inhabit the rare one where everything clicked. But another possibility is even more intriguing. What if these finely tuned parameters aren't random at all? What if they're the result of a deeper, underlying structure, a set of universal rules that inevitably lead to life and perhaps to the discovery of other life-bearing worlds beyond our own? This idea takes the anthropic principle from passive observation to active participation. If the conditions for life are hardwired into reality, then the same physics that made our existence possible might also contain clues for traversing the multiverse. Think of it like a cosmic escape room. The tools for interdimensional travel could be hidden in plain sight, woven into the very laws we're only now beginning to decode. Take quantum mechanics, for example. Its bizarre, counterintuitive behavior, particles existing in multiple states until observed, entanglement-defying distance might seem like quirks. But what if these aren't bugs in the system? What if they're features deliberately structured to allow transitions between realities under the right conditions? There's tantalizing precedent for this in nature. Evolution often repurposes existing structures for new functions, a fish's swim bladder becoming a lung, or dinosaur scales transforming into feathers. Similarly, the universe might have repurposed its fine-tuned constants as gateways. Dark energy, which accelerates cosmic expansion, could be the residue of a prior universe's traversal. The Higgs field, which gives particles mass, might double as an anchor, tethering our reality to others in ways we've yet to imagine. Even consciousness itself, the very thing that allows us to ponder these questions, could be less a product of the universe and more a mechanism, a tool evolved specifically to navigate higher dimensions. The eerie implication: we might not be the first to walk this path. Ancient megaliths, precise to degrees that defy pre-industrial technology, could be relics of civilizations that unlocked the first whispers of multiversal travel. Religious texts describing prophets ascending to heavens or descending into underworlds might encode half-remembered truths about slipping between realities. Even modern science's relentless drive to unify quantum mechanics and gravity could be more than curiosity. It might be an instinct, a subconscious pull toward the universal source code that governs all possible worlds. But here's the ultimate twist. If the universe is fine-tuned for discovery, then encountering other realities might not be a matter of if, but when. The anthropic principle doesn't just suggest we're lucky to exist. It hints that existence itself might be a doorway, and the key is hidden in the very laws we're still struggling to comprehend. So the next time you marvel at the universe's perfection, ask yourself, was it designed for life or was it designed for exploration? And if it's the latter, then the greatest journey might not be outward into space, but inward, into the fabric of reality itself, where every equation, every constant, every law is a signpost pointing toward worlds beyond our wildest dreams. What if the key to unlocking parallel universes isn't a high-tech portal or a cosmic anomaly, but a gun? This is the chilling premise behind the quantum suicide thought experiment, a hypothetical scenario that pushes the many worlds interpretation to its most extreme and unsettling conclusion. Imagine a subject hooked up to a diabolical device that measures the spin of a quantum particle, a particle that exists in superposition, meaning it's simultaneously spinning up and down until observed. The moment the device detects the particle in one state, it fires a lethal shot. If it detects the opposite state, nothing happens. Now, here's the twist. The subject's consciousness would always perceive the outcome where they survive. At first glance, this sounds like macabre fantasy, but the underlying theory is disturbingly sound. In the many worlds framework, every quantum event splits reality into branches. In most universes, the trigger pulls and the subject dies. But in the rare branch where the particle's spin aligns with survival, the subject's consciousness continues unaware of the countless timelines where their story ended. From their perspective, it would seem like the gun keeps miraculously failing over and over as their awareness slides into the one reality where they're still alive. The longer the experiment runs, the more statistically improbable their survival becomes, yet they would never experience death, only the eerie certainty that the universe refuses to let them go. The implications ripple far beyond a grim parlor trick. If consciousness truly follows the path of survival, then subjective immortality might be baked into the fabric of reality. Near-death experiences could be moments where the brain's quantum processes momentarily entangle with alternate branches, offering fleeting glimpses of lives cut short in other worlds. Even more unsettling are reports from suicide survivors who describe an uncanny sense of being pushed back into their bodies, as if some force overruled their demise. Could these be involuntary quantum jumps, the mind's desperate lunge toward a timeline where it still exists? But the experiment's real horror lies in what it suggests about free will. If every decision spawns new universes, then you reading this script is just one thread in an infinite tapestry of versions, some thriving, some long gone. The gun doesn't decide your fate, it merely reveals which branch you're on. Ancient philosophies spoke of fate as an unbreakable thread. Quantum suicide implies the thread isn't singular but a frayed rope with every strand leading somewhere different. Ethically, the experiment is a nightmare. No sane researcher would ever build such a device, but nature might already be running the test. Every moment of risk, every crossed street, every heartbeat could be a miniature version of the experiment, with our consciousnesses riding the branch of continuous existence while alternate selves vanish into silence. The universe wouldn't need a gun, it already has statistics. The most profound question isn't whether quantum suicide works, but what it says about the nature of reality itself. If consciousness can navigate probabilities like a river finding the path of least resistance, then death might not be an absolute. It could be a threshold one that, from the inside, you never actually crossed. And if that's true, then somewhere in the multiverse, another version of you is reaching the opposite conclusion, staring into the barrel of the same impossible thought, wondering if the trigger will ever click. Absolute nothingness terrifies the human mind, a void without light, matter, or even time. But what if that void isn't just the absence of everything? What if it's a universe in its own right, governed by laws so alien we're only beginning to imagine them? This is the spine-chilling premise of the null universe hypothesis, a theory that dares to suggest nothing isn't empty. It's a destination. To grasp this, you first have to rethink nothingness. The vacuum of space isn't truly empty. It crackles with quantum fluctuations, particles blinking in and out of existence. Even black holes, those cosmic pits of oblivion, still hum with Hawking radiation. But the null universe is different. Imagine a realm where even those faint echoes of existence are silenced, a place beyond energy, beyond entropy, beyond the very concept of something. It's not just dark, it's the absence of darkness, not cold, but the erasure of temperature itself. Here's where it gets stranger. Some physicists speculate that this null state isn't a passive endpoint, it's a stable configuration of reality, a parallel existence where the laws of physics as we know them cease to apply. Under this theory, our universe's birth wasn't just a big bang exploding from nothingness. It might have been a quantum phase transition, a sudden lurch from the null universe's perfect silence into the noisy vibrancy we call existence. Like ice cracking into water, but on a cosmic scale. The real shocker, we might already have hints of this null realm lurking in our universe, absolute zero. The temperature where all molecular motion stops has never been reached despite our most advanced cooling techniques. Laboratories have crept within billionths of a degree, only to hit a wall, as if reality itself resists crossing that threshold. What if that's not a limitation of our technology, but a boundary? A cosmic keep-out sign marking the edge of our universe and the doorstep of the null. Ancient Buddhist texts describe sunyata, the void that underlies all phenomena, not as emptiness but as potential. Modern quantum field theory echoes this. Even the vacuum teems with potential energy. Could the null universe be the ultimate source code, the blank canvas from which all possible realities emerge? If so, then mastering absolute zero wouldn't just be about cooling atoms. It could mean learning to rewind existence back to its null state, then reprogramming it into something new. The implications for travel are staggering. Entering the null universe wouldn't involve crossing space, it would require unraveling it. One speculative method involves Bose-Einstein condensates, clouds of atoms chilled so profoundly they behave as a single quantum entity. In these conditions, matter loses its identity, blurring into a state eerily reminiscent of the null. Now take it further. What if we could coax an entire region of space into this condensate phase, not just for microseconds but indefinitely? The result might be a pocket of localized nullity, a bubble where our universe's rules no longer apply, and where perhaps new rules could be written. Of course, the dangers dwarf even black holes. A null breach could be catastrophic, not an explosion, but an uncreation, a wave of nothingness spreading at the speed of thought, rewriting reality into blankness. Some theorists suggest this is the true nature of vacuum decay, the universe-ending scenario where a quantum fluctuation tips the cosmic scales into oblivion. Yet the most haunting possibility isn't destruction, it's discovery. If the null universe exists, then stepping into it might not mean vanishing, but awakening. Stripped of all sensory input, freed from time's arrow, a traveler might perceive reality's underlying structure for the first time. Mystics who speak of transcending the material world could have been describing this, not an ascent to heaven, but a descent into the silent foundation of existence itself. And if someone or something has already made that journey, their presence wouldn't leave footprints or radiation. It would leave absences, stars winking out not with a bang, but with a whisper, as if something unseen were pressing its fingers through the fabric of reality, testing the edges of a door we don't yet know how to open. The null universe might be the ultimate frontier, not because it's far away, but because it's hidden in plain sight, woven into the emptiness between our atoms, waiting. What if reality isn't just something we perceive, but something we actively create with every thought? The biocentric universe theory turns traditional physics on its head by proposing a radical idea. Life isn't just an accidental byproduct of cosmic forces. Instead, consciousness might be the fundamental building block of existence itself. Think of the universe not as a cold, indifferent machine, but as an immense, evolving thought, one that only takes shape when observed. This isn't just philosophy. Cutting-edge quantum experiments are revealing how deeply our minds might be entangled with the fabric of reality, suggesting that focused intention could do more than influence our lives. It might literally reshape the multiverse. At the heart of this idea lies the quantum observer effect, the strange phenomenon where particles behave differently when measured. In classic double-slit experiments, particles act as waves when unobserved, spreading out in probability patterns. But the moment a conscious observer checks which path they take, they snap into definite positions, as if reality itself waits for our attention before resolving into concrete form. Some interpretations go even further, suggesting this collapse isn't just passive observation, but an active creation. Your expectations, your beliefs, even your unspoken assumptions might be quietly steering quantum outcomes in ways we're only beginning to understand. Laboratories around the world are now testing these boundaries. In one startling experiment at the Princeton Engineering Anomalies Research Lab, participants focused their intention on random number generators, simple machines that spit out ones and zeros like cosmic coin flips. Over decades and millions of trials, the results skewed slightly but consistently in alignment with human intention, as if mental focus could gently nudge probability itself. Other studies explore how group meditation appears to lower crime rates in targeted areas, or how healers can influence biological samples at a distance. The effects are small, but they recur too often to dismiss as chance, hinting that consciousness might interact with reality's underlying code in ways our current physics can't yet explain. The implications for multiverse travel are staggering. If consciousness shapes reality, then shifting between parallel worlds might not require wormholes or cosmic strings. It could be as subtle as retuning your own awareness. Think of how dreams create entire landscapes from pure thought. What if waking reality operates on similar principles, just with stricter rules? Ancient mystics and modern psychonauts alike report experiences of lucid reality, moments where the solid world seems to bend or glitch under focused will. Even quantum physics now toys with retrocausality, where present observations appear to influence past events, blurring the line between cause and effect until it resembles more of a cosmic feedback loop. But the most revolutionary idea isn't just that we influence reality, it's that we might select which version of it we experience. The many worlds interpretation suggests every quantum possibility spawns a new universe. Biocentrism takes this further, proposing that consciousness acts like a radio dial, tuning into one frequency among infinite parallel broadcasts. Near-death experiencers often describe reviewing alternate life paths as if all versions coexist until chosen. Even mundane déjà vu could be glimpses of these overlapping timelines, moments where the mind brushes against roads not taken. The ultimate test wouldn't be technological, it would be psychological. Mastering this would mean cultivating unprecedented mental discipline, learning to sustain focus at levels that make Olympic athletes seem distracted. Tibetan monks who raise their body temperature through meditation, or yogis who slow their heartbeats to near stillness, might be early pioneers of this inner science. Future explorers might not launch ships into space, but journeys into the mind's deepest layers, not to escape reality, but to reshape it. Yet the greatest revelation might be this: if consciousness truly builds worlds, then we've never been mere passengers in the universe. We've always been its architects, wielding a power so immense we mistook it for ordinary perception. And if that's true, the first step to traversing the multiverse isn't building a machine. It's awakening to the fact that you've been navigating it all along. For decades, UFO sightings have been dismissed as weather balloons, secret military tech, or mass hallucinations, but what if the truth is far stranger? Some of history's most baffling encounters share eerie details that don't fit conventional explanations: crafts vanishing mid-air, moving in ways that defy known physics, or appearing alongside temporal distortions where witnesses lose hours of time. These anomalies have led researchers to a radical possibility. What if these aren't spacecraft from distant stars, but vessels slipping through the cracks between realities? The idea hinges on how UFOs manipulate spacetime. Witnesses consistently describe crafts performing instant 90-degree turns at impossible speeds, accelerating to Mach 20 without sonic booms, or fading in and out like mirages. These aren't just feats of advanced propulsion, they match theoretical models of objects transitioning between dimensions. Picture a sheet of paper representing our universe. A craft wouldn't need to travel across the sheet's surface to move from point A to B. It could fold the paper, punching through to another layer, a shortcut through higher dimensional space. This would explain sudden appearances, gravitational anomalies, and even the infamous falling leaf motion reported in the 1952 Washington, D.C. sightings where objects wobbled as if unmoored from our physics. Declassified government reports add weight to this theory. The Pentagon's Advanced Aerospace Threat Identification Program documented UFOs emitting electromagnetic pulses capable of disrupting nuclear facilities, not as weapons but as side effects of dimensional transitions. When a craft phases between realities, the energy required could warp local spacetime, creating transient EMPs. Even more compelling are radar signatures of objects appearing at altitudes with no thermal trails, as if they materialized from nowhere. Aviation experts have no explanation for this, but quantum tunneling, where particles teleport through barriers, suggests a mechanism. Scale that up, and you've got a craft tunneling into our universe from an adjacent one. The strangest evidence lies in the biological effects on witnesses. Close encounters often involve missing time, a hallmark of temporal displacement. In the 1961 Betty and Barney Hill case, hypnosis revealed memories of an encounter with beings who described their origin not in star systems, but in a reality parallel to ours. More recently, military pilots have reported entering voids or dark clouds near UFOs, spaces where instruments malfunction and time distorts. These could be localized spacetime fractures, brief zones where realities overlap. Ancient cultures depicted similar phenomena. Indigenous Australian sky beings emerge from shimmering portals. Medieval European paintings show aerial ships surrounded by luminous rings resembling modern descriptions of wormholes. But the most haunting question isn't how, it's why. If interdimensional travel is possible, are these visitors explorers, refugees, researchers studying us like lab specimens? Some abductees describe being shown apocalyptic visions of Earth, suggesting observers from realities where catastrophe already struck. Others report encounters with entities claiming to be future humans, descendants of a civilization that mastered dimensional travel. The common thread, a fascination with our timeline, as if it's one variant in an infinite multiverse salad bar. The implications rewrite the search for extraterrestrial intelligence. Instead of scanning stars for radio signals, we might need to probe spacetime seams for leakage residue from realities brushing against our own. Projects like the Large Hadron Collider already simulate microscopic black holes, which some theorize could briefly connect dimensions. If UFOs are tapping similar physics, their technology might not be hardware at all, but controlled space-time ruptures weaving through the cosmic tapestry like needles through fabric. Of course, skeptics argue these are leaps beyond evidence, but when military radar, pilot testimony, and historical records all converge on phenomena that defy known science, dismissing them outright is its own kind of faith. Whether interdimensional or interstellar, one thing's clear: the sky holds mysteries deeper than we've dared to admit. And the next time a UFO vanishes before your eyes, ask yourself, did it fly away or simply step sideways into a universe where you weren't watching? Imagine digging through the ruins of an ancient city. Except instead of pottery shards and crumbling walls, you're sifting through the quantum footprints of every atom that ever existed. This is the spine-tingling premise of quantum archaeology, a hypothetical future science where advanced civilizations could reverse engineer the past with such precision that they don't just study history, they reconstruct it atom by atom, thought by thought. But here's where it gets unsettling. If you simulate the past perfectly enough, down to the quantum states of every particle, does that simulation become indistinguishable from reality? And worse, could tampering with it accidentally spawn a new branch of the multiverse, a parallel timeline where the past you're observing becomes someone else's present? The idea isn't as far-fetched as it sounds. Right now, scientists use particle colliders to recreate conditions from the early universe, effectively rewinding time in localized experiments. Now project that capability forward 1,000,000 years. A civilization with mastery over quantum gravity and dark matter could, in theory, trace the entanglement of particles back to their original states, like running a movie in reverse. Every collision, every chemical reaction, even the firing of neurons in long-dead minds could, hypothetically, be pieced together from the faint echoes they left in the fabric of space-time. It wouldn't be time travel, it would be resurrection via quantum forensics, but the real paradox kicks in when you consider the observer effect. In quantum mechanics, the act of measurement changes the system being observed. If future archaeologists probe the past too closely, their instruments might inadvertently alter the very history they're trying to preserve. Picture a scientist in the year 12,000, adjusting a dial to observe Julius Caesar's final moments. The instant their machine interacts with the quantum data of that event, the superposition collapses not just in their simulation, but in a newly spawned branch of reality. Suddenly, there are two histories, one where Caesar died on the Ides of March, and another where some inexplicable quantum glitch altered his fate. The more they study, the more branches they create, until their quest to understand the past becomes an engine for generating new futures. This raises a chilling possibility. What if some of the anomalies in our historical record, vanishing civilizations, inexplicable artifacts, accounts of events that shouldn't have happened, aren't mistakes or hoaxes, but artifacts of future interference? The Antikythera mechanism, an ancient Greek device considered millennia ahead of its time, could be a fragment of a reconstructed timeline that bled into ours. Even Mandela effects, those collective false memories, might be ripples from histories that were overwritten by overzealous quantum historians, the ultimate irony. If this theory holds, the first civilization to master quantum archaeology wouldn't just unlock the secrets of the past, they'd become gods of the multiverse, consciously or unconsciously spinning off new realities with every experiment. And if they ever realized their power, the final step would be obvious. Don't just observe the past, step into it. A reconstructed Rome with all its atoms perfectly aligned wouldn't be a simulation. It would be Rome, and you could walk its streets not as a visitor but as a hidden architect. The only question is whether the residents would notice the stranger in their midst, or if history would simply bend to absorb you, like a drop of water vanishing into the ocean. The most haunting thought of all, if this is possible, then somewhere in the deep future, our present might already be someone else's excavation site, and we're the ghosts they're trying to resurrect. Every choice you make, every word you speak, could be under silent observation from a time that hasn't happened yet, by beings who don't just study history but curate it. And if they ever decide to tweak their simulations, you might wake up tomorrow in a world where the stars are arranged just a little differently, and no one but you remembers how they used to be. What if every doorway between universes, every wormhole, every quantum tunnel, every glitch in reality isn't a separate phenomenon, but a single equation waiting to be solved? A cosmic Rosetta Stone hidden in plain sight that could unify all 30 theories into one grand framework for multiversal travel. This isn't just science fiction. From Einstein's failed quest for a unified field theory to modern string theorists wrestling with 11 dimensions, the idea of a single, elegant equation governing all reality has haunted physicists for over a century. But what if the answer isn't just about our universe? What if the key lies in the spaces between them? Picture the universe as a vast symphony. Each instrument, gravity, electromagnetism, quantum mechanics, plays its own tune, seemingly independent. Yet beneath the noise, there's a harmony, a hidden conductor weaving everything together. The same could be true for the multiverse. Wormholes, dark matter, quantum entanglement. These might not be isolated oddities, but different expressions of the same underlying principle. Some researchers believe this principle could be a higher dimensional geometry, a shape so complex it folds every possible universe into a single mathematical structure. Others propose it's a quantum code, a programming language for reality where each universe is a subroutine in a cosmic algorithm. The clues are already scattered across our theories. Black holes and white holes might be two sides of the same cosmic coin, connected by an equation balancing destruction and creation. Dark energy's repulsive force could be the mathematical signature of neighboring universes pushing against ours. Even the Mandela Effect's shared false memories might be echoes of a deeper symmetry, like reflections in a hall of mirrors where every surface is another reality. Ancient mystics spoke of a world formula. Vedic scriptures called it Rita, the Greeks logos, a fundamental order underpinning existence. Modern science might be circling back to the same idea, armed with particle colliders and quantum computers instead of incantations. The breakthrough won't come from brute force. Solving this equation would require a paradigm shift as radical as relativity or quantum mechanics. A moment where seemingly unrelated phenomena suddenly click into place. Imagine realizing that the recipe for traversing universes has been hiding in plain sight, woven into the Fibonacci sequence in sunflowers, the branching of neurons, or even the spirals of distant galaxies. The most tantalizing hint, consciousness itself. If the observer effect in quantum mechanics proves that perception shapes reality, then the unified equation might not just describe universes, it might respond to them, evolving with the act of observation like a cosmic conversation. Of course, the risks are as vast as the rewards. Deciphering this equation could be like handing a toddler the keys to a nuclear reactor, unleashing powers we're not prepared to control. One misstep might collapse the delicate balance holding realities apart, flooding our universe with alien physics or erasing the boundaries that make us us. But the alternative is equally staggering, staying forever confined to a single slice of existence, never knowing what lies beyond the curtain, the eerie possibility. Someone might have already solved it. The universe is 13.8 billion years old, plenty of time for civilizations to rise, crack the code, and vanish into the multiverse's embrace. Their clues could be all around us in the perfect fine-tuning of physical constants, the unexplained structures in our cosmic backyard, or even the persistent myths of gods walking among us. The final theory isn't just a tool, it's an invitation, one that might have been waiting since the first stars ignited. And when we find it, we won't just be unlocking the secrets of other worlds. We'll finally understand our place in a symphony of universes, each note a reality, each chord a dimension, and the silence between them, the space where the equation hums, waiting to be heard. From cosmic strings vibrating between realities to the eerie Mandela Effect suggesting we've already slipped between worlds, the quest to unlock parallel universe travel defies everything we thought we knew about reality. Each theory we've explored, whether it's black holes birthing new universes, dark matter as the gravitational echo of another dimension, or the spine-chilling possibility that consciousness itself tunes into alternate timelines, paints a picture of a multiverse far stranger and more accessible than we ever imagined. Some of these doorways might already exist, hidden in the quantum fabric of the universe or woven into the very structure of our minds. Others could require technologies so advanced they border on magic, harnessing the energy of dying stars, rewriting the code of space-time, or even riding the collapse of reality itself into a new beginning. The most startling realization: we might not be as far from breakthroughs as it seems. Quantum experiments today are already probing the edges of entanglement, while cutting-edge telescopes hunt for anomalies in the cosmic microwave background that could reveal collisions with other universes. Ancient myths and modern UFO encounters alike hint that someone or something might have already cracked the code. The line between science fiction and scientific possibility grows thinner by the day. Yet for every tantalizing clue, there are still cosmic locks we can't yet pick. Wormholes collapse before we can traverse them. Dark energy's secrets remain just out of reach. The sheer energy required to twist reality into a bridge between worlds dwarfs anything humanity can currently muster. But remember, every impossibility in history, flight, space travel, splitting the atom, was once dismissed as fantasy until the moment it wasn't. So where does that leave us? On the edge of discovery, staring into the void with tools and theories that grow sharper by the day. The greatest adventure in existence might not be outward to the stars, but inward through the hidden cracks in reality itself. And that brings us to you. Which of these 30 theories resonates most? Is it the cosmic simplicity of quantum tunneling, the haunting elegance of the holographic principle, or something even wilder we've yet to imagine? The multiverse isn't just a puzzle for physicists, it's a conversation for all of us. So drop your thoughts below. Which doorway do you think leads to the next great leap? The answer might be closer than any of us realize.